Plotly and Dash. So Plotly and Dash do visualizations of stuff. It's graphs. It's all about graphs. Um, a lot of people are familiar with Matplotlib, which I'll show in a moment. Oh, and I forgot to add here like a plug for my company. So I work at Pagaya something, Israeli company, and we're looking for a data scientist to join my team of real estate stuff. So if you're interested, please contact me. All right, that's that. So I want to show you some stuff with Plotly and Dash. It's not too much. And I needed a data set, and I just took a data set I'm working with at work, which is the American Community Survey. So the US just gives lots of data about stuff that's happening in the US, whether it's demographics, it's like how many people in Dallas in the last 5 years have worked in the tech industry, or how many people work in, or how many people have internet access in New York. And then it's like lots of categories and stuff. So they have an API that you can just go and look for it. It's just this website, API, Census data. I'll put up the code on GitHub later and put a comment in the meetup, but I forgot to do that. And you need an API key, which I've hidden masterfully here. And okay, so I'm gonna test that. So just to show you what some of the data looks like, you can get, so they provide like a big page of all the variables in their table. And so the table kind of looks like this. There's a variable name and label and a concept. It's like a CSV that comes back from the API. It's actually not a CSV. It's a bit annoying, the format, but anyway. So I've pre-selected two interesting variables. One is the total amount of people who have a computer. And I'm going to do everything on the county level. I've written it somewhere here. I just do county. It's hard-coded in. So the US is divided into sections, like there are states. In states, there are counties. And in counties, there are census tracts, and then there's block groups and then blocks. So at the end, there's like a block. A county is a bit bigger than a city. There are 3,000 counties in the whole of the US. So we're going to have 3,000 data points for everything. So I'm just gonna, I called the API with my function that's above, and it looks like this. So MS, which state is MS? Maybe it's Mississippi. And then, because MI is Michigan. So MS has, so I'm taking people who have, the ratio of people who have a commute of less than 5 minutes to work. So in County 151 of Mississippi, less than 5% have a very short commute to work, but 75%, more than 75%, have a computer. So that's nice. So the usual thing that people who learn Pandas get to know is the dot plot method, and by default it uses Matplotlib. And this is the kind of thing that you would do with any initial data exploration, whether you're a data scientist or anything else. Like even if you have logs of stuff and you just want to see a plot of times or of something, of whether it's timestamps or which users created what logs, then you can stuff it in the data. You can stuff into a Pandas data frame, and then this. But that's not the focus. So the thing with this plot is that it's just a lot of points. It's pretty fast to make, but it's hard to know. It's hard to see more stuff in here. So let's do Plotly. So the only thing I need to do is import Plotly Express, and then I'm gonna do Plotly Express.scatter. It's data first argument, and I've heard some people call this data first, and I think they meant the argument, but it's more than that. It's data first. Anyway, so I just put my X and Y, and we can see what happens now. I'm on a MacBook Air, so it takes some time. But all right, so it's the same plot. It's scaled a bit, but that's okay. But then we can say that it's actually interactive. So if I go on, then I can see the points, and we can also zoom in. There's zooms and stuff, and that's nice. Okay, so it's not a big deal over the first plot. I can zoom, okay, great. And I can see individual points. So let's add some data. So what I'm going to do is I'm going to get the same thing I got before, the same lines to get a pandas data frame. It's just 3 lines. I'm calling my function to get the variable that I've pre-selected, but I'm going to do this for 2 years this time. And I've put in my function here. So I'll just show you maybe this. So this is my new data frame. It's I have 2 years now, 2017 and 2018. Okay, and this time what I'm going to add, oh wait, I missed this one. So I'm going to add the hover data of state and county. Okay, so now when I go over a point, now you can see that this point corresponds to California, County 91. I could also get somehow the names of counties. Counties have name, but I was lazy. But then you can also go down to these low ones. What are these places that have very few people have computers as a percentage? And you can see that the state is Puerto Rico. So Puerto Rico is in the data set, even though it's not official. It's not really a state of the US, but they joined it. There's also, I think there's also Guam and Virgin Islands here. But since they're really small, the data is, I think it comes as none. But anyway, so you can see here that Puerto Rico has very low percentages of computers in their counties, but also very tiny commutes. So that's something, you know, they don't have to go far for work. Okay. So the only thing I did here was added the hover data, state and county. And now I do it for 2 years. And once I'm doing it for 2 years, I'm just going to add one more thing. Color equals the year. So these are just arguments to the Plotly express. So it's very similar to the matplotlib call, but it has quite a bit of power under it. So now once I've given color and set it to year, and I've set the year in my function that calls the API. I just set a column of year, and then it's up there somewhere. But then boom, so I just have a data frame that we know it has these columns: tiny commute, has computer, state, county, and year. And all 5 columns, you can now see them in this graph. So we can go now here down, and we can see that indeed there are 2 years and Puerto Rico and stuff. And at this point, I'm going to set it, let's zoom into here. I'm going to click 2018. And you can click here on the legend on the right. And this lets you just filter the data for easy viewing. And I think when I look at this and I filter out 17 or the opposite, it seems to me that a bit more people have now computers in every place than 2017, because you can see you can see more blue coming under the red than the opposite. But I think just via visual, I think that's true. And then we can go and check this stuff. You know, we can actually look at the data. Is it true that more people now have computers? But if you look here at Puerto Rico, so 23. So you can see that in County 23 of Puerto Rico, actually a bit less people have computers, and for some reason they have a higher commute time. That's interesting. I don't know what happened between 2017 and 2018, but they now have to go further.
Maybe it's a survey, so this is maybe a sampling error.
It's true. It is a survey. And there is sampling error. They actually provide also in the API. I'm filtering it out, but there are columns of sampling error, and then we could actually check if we could add bars here, but I actually don't know how to do that. I've never done that at my work, so like with all this data, so I didn't want to complicate myself. All right, cool. So at this point I said maybe it's a lot of this stuff is about how big the state is. So what I'm going to do, I'm just going to do some Pandas stuff that is not the focus of the talk. I get the ratio, I get the two variables from the API, and then I add one more variable, and I know that this is the variable of the population size. So this is just the estimate of the total population for each county, and I'm going to do it for each year, and just rename it to the column pop. All right, so this gets me my data frame, and then all I'm going to add on the previous plot, so I still have X, I still have Y, I still want my hover data to include state and county. I'm going to add pop, so it's easy to see. And then the color, I'm going to now give a different color to points, and it's going to be the logarithm of the population size. It doesn't have to be log here, but I'll explain in a second. So all I've really added is this color. I'm adding another dimension to the visualization. All right. So this is this. So now there's a color bar. And here's the reason why I'm applying log is because the numbers of population, they have a very wide range, but the color that's the easiest to do in Plotly Express is a linear scale. You can do a logarithm scale, but I was like, meh, I'll just do apply. That's a Pandas thing. It's whatever is nicer. So let's put that aside. So what we can see here is that I guess hotter colors? No. What is hotter, yellow or blue? Is blue hotter?
Yellow is hot.
Yellow is hot.
Blue is cold. Like
All
on
right.
your faucet in the bathroom.
Sun is yellow.
It doesn't have. All right. So the hotter colors, we can see. So the hotter colors are bigger populations. So we can see that if we go here to the top left, we can see here NC is North Carolina, and the population of this county is like 1 million something. And then if we go to some blue, a cold county, Texas, some county that has only 600 people. So you can see, and now here it's really, I think it's pretty clear to the eye. If you're not colorblind, then you can see that the more population you have, the more people have computers. So the more we go, so the colors kind of correspond to the y-axis almost. And also there's something about the tiny commute. So there's less people with tiny commute, with less than 5-minute commute in the larger populated counties. So we see that, so if we go here somewhere, so what's RI? I don't know, let's go. Georgia, GA. So in Georgia, in some county in Georgia, there's quite a rather big population, 75,000. And so they don't have a big percentage of people who have less than 5 minutes commute to their work. So they have to drive to their work. And if we go around here, we can see that, I know UT is Utah. So Utah, some counties, NT and, oh, MT is appearing here. Utah appears twice. So just some counties in Utah, small populations, and then lots of people have a percentage of these 700 people, a big percentage, have a very short time to work. All right. So what's cool here is that so to generate this plot with Plotly, all I needed to do was import Plotly Express once I have my data sorted, and then it's just setting each of the columns to where I want to put them. So I choose my X, I choose my Y, I choose what's in the hover data, and there's also a symbol here. I forgot about that. I put it, but it's a bit hard to see. So like there are circles and there are diamonds, and that compares the 2 years. I don't think that's such a good visualization. It doesn't really work. And there's also a bit of a bug here that there's overlap with the years on in the legend. But you can see here, I can still filter out my years. I think I saw an open issue about this overlap, and they'll deal with it, okay, by the next talk. So yeah. So we can so let's say we don't really see the year, but then we can see here, we can see the population, and we can see the computer, how many percentage of computer and how many percentage have a tiny commute. And when we want to zoom in to want to understand a particular point on the extremes, we can go over it, we can hover and just see the state, the county, and the actual nominal population size. So in some sense, we can see, I wrote it down here, so I don't do it in my head. So something like, I'd say four plus dimensions. So maybe the year is down, but I think the hover info is worth more than epsilon. So there are at least 4 dimensions here in one plot, and it was very easy to generate. So that's that. Okay, so then when we want to publish this, say in a Slack channel, or just send to someone, or even keep to ourselves, or put on our I don't know, deploy it automatically to our GitHub pages, then we can download, there's just a button here, download plot as PNG, and then it actually creates the PNG, and boom, this is it. You can now send this to people. But this again suffers from the same problem as the matplotlib. It's just a static image. So if we have the option to, if we can save HTML and send it to people, then here's the line. So instead of just calling scatter, all I'm adding is putting it into a variable. I'm assigning it, and then I can just, so fig.toHTML returns the thing. So if we go here, boom, and then it's all local, but I'll do this anyway just because it's the UI. So I have now an HTML file, and it's just the plot, and it's with all the stuff behind, basically the HTML and JavaScript that power this visualization. Cool. Any questions about that? All right. So
I'm sorry, if you save this workbook as an HTML, I guess the interactive plots would stay.
yes, they stay. They do. Yeah, exactly. I've had trouble. It's when I put it up on GitHub. I just put the notebooks up on GitHub, but GitHub doesn't like when you put JavaScript in your HTML, so that doesn't work. But just in the code as a file. But yeah, except that, it's just HTML. It's pure HTML and vanilla JavaScript, and it just works. That's why it's also a bit of a big file. Yeah, so Matthias is writing that in physics, this is what I was thinking, that blue is the hot, never mind, let's keep going. So maps. So in real estate, I don't just want to see graphs of XY. I want to see stuff on a map. So I'm doing here a bit more of Pandas stuff. So I always do everything again, just so you can always evaluate all this. Also, the first part is just what was before. I'm merging on the 2 variables that I have, and then I add a variable. It's not so interesting. And then I found on the Census website, they have this is a CSV. They just have a nice CSV that gives you like the longitude and latitude of every county. So this is just some Pandas, some stuff to get.
Dror, I'm sorry. Can you let Peter in? He's in the waiting room.
Cool. Thanks. All right. So once I have the data frame, so I've just merged a few CSVs and a few API calls. So I just have these columns. I've added longitude and latitude by merging on state and county. All right. So instead of calling scatter like before, this time I'm just adding this word Mapbox, which is an online service that draws stuff on maps. And I actually choose the Mapbox style OpenStreetMap. Otherwise, you have to have an API, which I don't have, and this is free. This is a thing you learn to do when you read the blogs. And I just changed the margin because it's nicer. But really, all I'm doing is calling scatter Mapbox, data first, longitude, latitude. Let's run it. Okay. All right, so it puts this, it's a bit slow, and I'm gonna use my mouse wheel button. You have to believe me that that's what I'm doing. I'm gonna zoom out. It's just doing the mouse, and these are the centers of all the counties in the United States. But then you have to keep going because actually there's also Puerto Rico here, and Hawaii, and Alaska. Wow, isn't that cool? Okay. But where's all my data? So again, I want to add dimensions to my view, to my visualization. So I'm going to add a color. I'm going to do the color will be the percentage of computer. I'm going to change the scale a bit, but it's not necessary. It's just I found it to be nicer. And I'm going to make the size the dimension for how many people have small commuting time. And then it's the same. I'm going to mute that. So I'm just adding. And hover data, this is like in the scatter, it's the same argument. I just put the names of the columns. So I don't have to do much to make a scatter plot into this thing. Wow. All right, so what do we see here? So color is, oops. All right. So color is the percentage of computers. So hot places, hot colors, colloquially hot, are places where a lot of people have computers. So you can see like on the sides and here, really most places have a lot of computers. So it's a bit, there's some kind of gathering here that's hard to say. You know, Georgia is somewhere here, and I guess Arkansas is here, and here I think it's Texas, or what's NM? New Mexico. So New Mexico has quite a bit of low
But yeah,
percentages.
that's human hot, not physicist hot.
That's right. That's right. And the size. So the size I put to be how much of the commute. So the bigger the circle, the more people have a very short commute. And now you can really see how on the West Coast, most people have a long commute, and on the East Coast kind of also. And then in the middle, it's just lots of people. So I guess this will be the Midwest. So lots of people in the Midwest just have very short commutes, which I found interesting. Like I didn't get that from before. I wonder if this matters for anything. All right. So we've lost a few dimensions. We really can't see the year here unless there's no year at all actually. I didn't put year anywhere, and also from before we had, what else did we have? The population. There's no visualization of the population size. So I had to discard 2 dimensions, but we gained 2 dimensions, the latitude and longitude. So we still have at least 4 and then plus epsilon when we hover, dimensions in one graph. All right, so I'm just gonna do a few more minutes and wrap up. So again, this can be saved in the same way to HTML, just fig to HTML, and then boom, it saves it, and you can then just open it. Do it. It's there. This is all local. It's just nicer in the GUI to do it like this. And then this is an HTML file that you can send over Slack even. Slack is fine with this. I don't know if you can see it, but I called the Slovenian Slack Slock, and then so you can go there and just send it. Here, look, commute times, my Slack friends. Okay. So that's that. All right. So there's also a huge Plotly gallery. It's just insane how many things you can do. I mostly do scatter plots and map plots for my work, but it's just insane how many things you can do. Like Plotly. So Plotly Express is the easy way to go. If you want to do multiple figures and stuff, then usually you want to do a bit more. Then you use the more native API that you can read about. I'm just gonna scroll a bit. Yeah, graphs. Lots of graphs, and the code for all of these is really minimal. That's what's cool. And then I remember I'm supposed to scroll all the way down. Let's see, because if you scroll, it's a long page. Lots of in the gallery. Lots of plots.
If you were on a proper computer, you could press end.
But I think it's also loading still, and it's just really slow. Boom. At the bottom of every Plotly page on the documentation, they say, what about Dash? Dash is an open source framework. So what's Dash? Dash is just like, it's kind of an extension of Plotly. It's built on top of Plotly. It's a way to do applications, web applications that can serve your figures or more stuff. And then it's really easy to not only give an HTML to your fellow colleagues or friends, you can also serve an actual page that is more interactive than just JavaScript, that can also interact with Python in the backend. You don't need to know any JavaScript to do this unless you want to get really fancy or if performance is an issue for you. I didn't get into any JavaScript I'm just going to show you one thing because I want to end. You do have to know a bit of HTML. If you don't know any HTML at all, then you'll have to like maybe read a blog post or something, because like to do a div, you have to know that there's a thing called div in HTML. So already in this one example that's very basic, you have to know about divs. So if you've never seen HTML, I think it doesn't really work. But okay, so I want to show you what I've done with the dash. So I just took the example there, and I already have a fig from above. So it's this figure. Call it clear. So this starts a server at this address. It just starts it. It doesn't have to be from a notebook. I could run this from a file, and then it serves the figure. So now there's an address, and if I'm on a network, or if I want to put this on a server or like on the cloud, then this is it. This is enough. This is running on Flask. There's the normal security stuff that you need to be aware of, but you can put it into Gunicorn. I don't know how you pronounce that. All right, so I'll just finish with, I did some stuff. I added a data table. There's more code here. This will be on GitHub. I wanna do it. So what I've done here is I've added a div, and in it I put a data table. So there's a lot of code here actually, but it's all configuration. And I kind of I just took it from some YouTube that is here. So I searched Plotly+Dash, and then some guy said, here, do this, editable equals false. And the most important line here is this. I think everything else can actually be taken down. It will almost be the same. It's just styling. So I take my ACS variables, which is the data frame that I got of what variables exist. And then I'll just show this one. I put a div that's called scatterplot. And then what I do is I connect things. So when things change, I'm making a function that says when something changes in the inputs, then change some output. And then there's some code here that is it's just pure Python that returns a dash object that all it really has is a scatter plot. So the main thing here is I'm going to return a graph of that all it has is a scatter plot, and using the decorator above is the way to say how to connect inputs to outputs in Dash. And then let's go to localhost again. All right, so this is the ACS table. These are all the variables that exist. And these are over here, they're the pre-chosen variables that I already did. So it's the commute and do they have a computer? And this is one graph, and this is the other graph. I changed here what I show. There's no size. There's just color to make it a bit less hectic. So the data table of Dash, it provides me this thing. All I had to give it was the data frame, and that was it. I didn't have all the configuration there is about the sizes of the stuff and how I'm doing left instead of right alignment. But then we could go here, and now we can just go so wage, for example. So let's take Let's do this. When I didn't bother to do a fancy selection thing. Whoa, what's this? Get out of here. So I have some kind of bug. I don't know. It worked before, but this is the live demos. So you can kind of see in the background that things have changed, and it changed to my two other fields. One is wage now, wage or salary in the last 12 months. So if there wasn't the bugs here, I could show you how you could see how the more wage you have over the years, the more people, the higher the wages, actually the less people have small commutes. So more people have long commutes. So high wages, high commute. And here's the map. It's supposed to kind of show it also. So again, in the middle here, you can actually see that there are lower wages, and the high wages are on the sides. So yeah, so that's Dash.